In this lesson, we're going to learn how to simplify rational expressions. Now, remember that a rational expression is a quotient. That is, it has a numerator and a denominator. And in the numerator and the denominator, we will find a mathematical expression involving variables. So when we're asked to simplify it, basically what we're looking for is opportunities to cancel terms from the top and the bottom. Okay, well, here's the catch. You have to remember you cannot cancel across anything other than multiplication. So when we look at this rational expression here, we can see that we have x squared minus 4 up top and 2x squared minus 6x minus 20 on the bottom. And if we were to come along and say, you know what, I think that I can cancel this x squared with that x squared, well, no way. You can't do that because of the fact that there is subtraction happening between the x squared and the 4, and we've got subtraction down here in the bottom. Well, so how do we cancel then? How do we look for opportunities to write this in a simpler manner? Well, we're going to use a technique that we've learned in previous lessons called factoring. And so by factoring, we're going to be able to write this rational expression involving products, that is, joining terms together by multiplication. So let's look at the top first. So x squared minus 4, well, that clearly is a difference of squares, and we'll be able to write that as x minus 2 times x plus 2. Perfect. Well, let's look at the bottom. It's a trinomial, and we know that when we're factoring trinomials, the first thing we should try to do is look for a greatest common factor. And I look at the coefficients in front of each of the terms, and I see that not only is the x squared term even, but so is the x term, and the constant term at the end is also even. So I can factor out a 2, leaving me with x squared minus 3x, and then minus 10. Okay, well, up top, we still have the x minus 2, and we have the x plus 2. And then the trinomial that was created after we common factored out the greatest common factor of 2, well, that's a simple trinomial. I'm looking for two values that multiply to give me negative 10, yet when I add them, I'm left with negative 3. And I think it's pretty obvious this is going to turn out to be x minus 5 and then x plus 2. I can always check my answers as I'm going through. X times x is x squared, plus 2x, minus 5x, there's the minus 3x, and then negative 5 times 2 is negative 10. Okay, well, it looks like things have gone quite well because now I have two terms in the numerator joined by multiplication, three terms in the denominator, again, joined by multiplication, which opens up the door to canceling terms that match. I can cancel the entire x plus 2 term on the top with the entire x plus 2 term on the bottom, and that allows me to write this as simply x minus 2 over 2 times x minus 5. Okay, there is the original rational expression written in a simpler form, x minus 2 over 2 x minus 5. Now, what if we were asked to also state the restrictions? Well, what we're going to do is, once we factor this and we get the rational expression written with the denominator as a series of terms multiplied together, I want you to look at the terms before you cancel. So that is in this step right here. This is where we're going to look. And you'll notice that we have two terms here. And what I'm concerned with is what values of x would cause either of those terms to equal 0. Well, in the x minus 5 term, we would never want x to equal 5, because that would result in 5 minus 5, 0, and the whole denominator would turn to 0. You cannot divide by 0. Similarly, the x plus 2 term, I would never want x to be negative 2. Why? Well, negative 2 plus 2 is 0. Again, the entire denominator would turn to 0, causing an error when I try to divide by 0. Well, what is the difference between the x minus 5 and the x plus 2? Because after simplification, only the x minus 5 remained. Well, that means that this restriction of 5, because it's associated with the one that's stuck around, this is an asymptote. Okay, that's what the 5 is. Well, what about the restriction that canceled, that vanished? This restriction of minus 2, this will be a hole on the graph. All right? Okay, let's try another one. Okay, let's say we were asked to simplify this rational expression right here. How do we do that? Well, we're going to do the exact same thing. We're going to go through and we're going to try to write this in a manner that results in multiplication between terms on the top and on the bottom. Well, we don't really need to do any simplification down on the bottom because we just have x plus 7. And I'm just going to put that in brackets indicating that it's a term. But up top we have a trinomial, and I might take a look at it and see if I can GCF anything out. And certainly the 2, if it was even, that will come out, but it doesn't divide into 11 or 21 evenly. So we're kind of stuck here. But I'm going to take this 2x squared plus 11x minus 21. It's a hard trinomial, and I'm going to go through the process of trying to factor this. Okay, well, how do we go ahead and do that? Well, if you recall, we take the 2 and the negative 21 and we multiply them together. So that is negative 42. And then I go hunting for the factors of 42. Well, it's 1 and 42, 2 and 21, 3 and 14, and then 6 and 7. Those are the factors. I know that I need 11 when I add these two factors together. And this negative in front of the negative 42 is telling me that one of these factors will be positive and one will be negative. Well, which is which? Well, because I have a sum of 11, positive 11 after adding them, I better make sure that the larger values are positive and the smaller values are negative. And then I just look at them, add them together, and say which one of these would actually give me a sum of 11. And I think you can clearly see it is this pair right there. Negative 3 plus 14 equals positive 11. So what do I do then? Well, I'm going to take this 2x squared, and instead of writing plus 11x, I'm going to add 14x and subtract 3x. And that plus 14x minus 3x, that is the exact same as 11x. And I still have the minus 21. Well, let's take a look at just these first two terms here and common factor out anything that we can. If I common factor out a 2x, what remains inside is x and then plus 7. Okay, let's take a look at these two terms here. Let's try and common factor something out. Well, if I common factor out a negative 3, I am left with x, careful with the sign here, plus 7. The x plus 7 is common. So that means that we've got an x plus 7, and then what remains is your 2x minus 3. Okay, so this trinomial, this hard trinomial, can be factored into x plus 7 and 2x minus 3. So I can write that x plus 7 and 2x minus 3 up top there. Okay, well, now the simplification part starts. We should be able to cancel, and sure enough we can. There's an x plus 7 and an x plus 7, and the resulting simplified rational expression is just simply 2x minus 3. Now, that's a linear function, so if we were to graph this, we would actually get a straight line. But what are the restrictions? So if we were asked again, are there any restrictions on this rational expression? And sure enough, there are. We canceled the denominator up top here. So we're going to go back to this step right here when we still had the denominator and it was in a factored form. And we're going to say that the restrictions are x cannot equal -7, because a value of -7 would say -7 plus 7 would get a 0, and you cannot divide by 0. So the question becomes, is this -7 right here, is this an asymptote or is it a whole? And because it canceled and it wasn't still around at the end of our simplification process, we know that this is in fact a whole. So there are two examples of simplifying rational expressions. Just be very careful that when you are canceling during your simplification, that you only cancel across multiplication.